Hi students, in this video we are going to learn how to add and subtract rational expressions. So before we do this, these two problems that are on the screen, I just want to do a quick warm-up of how to deal with fractions. A quick review. So remember, when you have fractions like 1/4 minus 2/4, we know we can subtract them or add them or whatever because the denominators are the same. So we would just gather the numerators together. We would do 1 minus 2, which is -1/4. That would be our answer. So those are the easy problems with fractions. Now, what if we have a fraction where the denominators is not the same? What do we do? So if we have 4/5, let's say 4/5 plus 3/2. So let's see, we have to eliminate it properly. 3/2. So here, since the denominators are not the same, we can just gather the numerators together and add them up. So in order to add, we have to make the denominators the same. So we'll have to, if both the denominators are different and they're not factors of each other, I would multiply this denominator with 2, the opposite one, and this denominator 2 with the other denominator over there with 5. So whatever I multiply in the denominator, I multiply in the numerator also. And then what do I get? This numerator becomes 8, 4 times 2 is 8, over 5 times 2 is 10, and this numerator becomes 5 times 3 is 15, over 5 times 2 is 10. We make the denominators the same. We can combine the numerators now. 15 plus 8 is 23/10. So this is the idea of what we have to do when we have different denominators. We have to multiply the missing factor, or whatever factor that we have to multiply it with in order to make them equal. We got to do what it takes. So this is the same idea we have to use in rational expressions. So let's do the first problem over here, which is b square over b square minus 2bc plus c square minus b over b minus c. Now, whenever we are dealing with rational expressions, we have to remember to write them in factored form. That helps us a lot. Okay, so some of the rules that we usually use are, if it's a trinomial, the two things we can check is the sum product one. Can it be factored using the sum product method, or can it be factored using the perfect square trinomial way, or any other different options? Okay, so in this case, when I'm looking at this expression right here, just the denominator over here, I'm doing question number 1. You guys kind of ignore question number 2 for now. I'm going to have to take the space on this side also for this question, so don't get confused. Okay, I'm not doing this problem now. So for question 1, I'm going to do the factoring of the denominator on the right side. B square minus 2bc plus c square. So when I look at this problem right here, I see the first and the last terms are squares. So does b square have a square root? Yes, we know it's b. Does c square have a square root? We know that the square root of c square is c. And the sign of the middle term is negative, so I put a negative sign in the middle, and I can put them as parenthesis square. Always double check to see if this is a correct way to factor by see if the middle term matches up when you multiply all three of them together. So 2 times negative c times b is negative 2bc. It does match up. So the denominator here can be written as b minus c the whole square. So I leave the numerator just like that as b square over b minus c the whole square minus, rest of the question minus b over b minus c. So now remember, our goal is to make the denominators the same. So if we look at the two fractions, we can already see that the denominators can be made equal if by multiplying this denominator over here with another b minus c, because This denominator already has two b minus c's. It's b minus c the whole squared. So to make them the same, this side also can be multiplied with b minus c. So when you do whatever you multiply with in the denominator, you got to multiply with the same stuff in the numerator also, with the same number or term or factor. So this becomes b squared over b minus c the whole square. I just bring it down just like that. And that becomes b times b minus c over b minus c the whole square. Now since the denominators are the same, we can write the entire numerator together under one denominator like that. And this side becomes b squared, and we know that when we have parentheses, we have to distribute. So negative b times b squared, negative b times b becomes negative b squared. Treat this as a negative b, okay? So negative b times negative c becomes positive bc. And from here, we know that negative b and positive b will cancel, and your final answer is bc over b minus c the whole square. So that is our final answer. So the key to these kind of problems is that factorize the numerators and denominators, and then try to make the denominators the same by multiplying whatever missing factor is needed, and then just bring it all together and simplify and write it as a simple in the simplest form. So that's the first question. Now let's try to do the second one over here. So in this case, I'm going to have to clear this left side because I need the space to show the factorings, to show how to factor the denominators over here. Okay. So let's begin by factoring the first denominator of the second question. The first denominator is x squared minus 1. So when I look at this, I see that this is a binomial, and there is a difference or a subtraction in the center, and these two are squares. I can relate this to the identity a square minus b square. Okay, so this is like 1 square. 1 square is just 1. So that's how I'm going to compare this to. We know that a square minus b square can be factored as a plus b times a minus b. Alright, so this can be factored as, instead of a we have x, instead of b we have 1. So we can write that as x plus 1 times x minus 1. So question number 2, I'm going to write it over here. The first denominator becomes x plus 1 times x minus 1. This denominator was factored like that. Minus the other fraction, 2x over. Now let's look at the next denominator over here. What do we have? It's x squared plus x minus 2. X squared plus x minus 2. Can we factor this using the perfect square trinomial? The first and the last terms, do they both have, are they perfect numbers? Do they have squares? No, because 2 doesn't have a square root, at least not a rational one, so I can't do that. So the easiest way to do this is the sum product one. You have to find two numbers whose sum is positive 1 and product is 2, negative 2. So we know that we can get 2 by multiplying 2 times 1. So in order the product to be negative, one of the numbers have to be positive, one has to be negative. When we add them, we have to get a positive 1. Okay, we have to get this. I'm not going to put the 1 there all the time, but we know if there is no number that's a 1, that's how I get the 1 over here for sum. So when I add them, I'm supposed to get 1, positive 1. So the bigger number has to be positive and the smaller number has to be negative. So I can write the denominator here as x plus 2. I can factorize it as x plus 2 times x minus 1. So now this is going to be a little bit longer problem. If you look at both the denominators, they both have x minus 1 as a common factor. Okay, so this denominator is missing the factor x plus 2. So I'm going to write x plus 2 on the numerator and the denominator. This denominator, if you look at this side, is missing the factor x plus 1. So I'm going to write x plus 1 in the denominator and in the numerator. Okay, so now if you look at these, we know that we have the same denominator on both sides. The factors are just x plus 1, x minus 1, and x plus 2. See, they both have the same factors as x plus 1 here, x plus 1 here, x minus 1 here, x minus 1 here, and x plus 2 and x plus 2. So both denominators are the same. So when we write this, we are going to distribute x times x is x squared, x times 2 is 2x. This is a minus 2x, so minus 2x times x is negative 2x to the second power. Negative 2x times 1 is negative 2x. So we're going to look and see, is it possible to do any simplification with the numerator here. So we see a positive 2x and a negative 2x. We go ahead and cancel that. Can we combine these two? Yes, we can. We can get a negative x squared, because we know that this is a 1, right? So 1 minus 2, because x squared and x squared are like terms, we can combine the coefficients of the like terms, and we get our numerator as negative x squared, and we're going to write the denominator as x plus 1, x minus 1, x plus 2. So that is our final answer. So remember, even though this looks like a lot, it's really not a lot. All you have to do is factor the denominators, or factor the whatever is given to you. Write it in factored form is the first thing that you got to do. And then you got to make sure that you supply any missing factors that will make both denominators the same. So this side had x plus 2 missing, so I supplied that. This side has x plus 1 missing compared to the other, so I supplied that. So we multiply the same thing on the numerator and denominator, distribute, simplify, and write the answer in the simplified form.